Hello, my name is Keshwani. This Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 296. Data analysis problem number 2, and today is our lesson number 179. Let's take a look at it. It says the number of passengers on 9 flights are as follows, and they're asking, and they also give you the standard deviation, which I'm not going to worry about right now. The standard deviation they tell us is approximately 10.2. Our first job is to figure out the mean, median, and mode, and the range, and the interquartile range. None of those are going to require us to use the standard deviation. The part A does not require standard deviation, so we're not going to worry about it right now. Now, before we can do any of the work, the very first thing we need to do is arrange these numbers in order, because they're not arranged obviously. It makes life much easier to do the work if they are arranged in order. So let's start here. 19 is the lowest one I see here. 19 is gone. Then I see a 22, a 22, a 21. There we go, a 21. That guy is gone. I see a 22. I see another 22, 33, 31, 28, I see 28, I see a 31, I see a 33, don't cross out the number before you write it, 33, I see a 44, and I see a 50. That's it. Do we have 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. Okay? Now, if you watched my video yesterday, which I hope you did because you should go in sequence, I talked about the fact that there are 2 ways of calculating the average. It sounds like a very simple concept, which it is obviously, and you may wonder why this guy wants to talk about how to figure out the average. Everybody knows how to figure out the average, which is the traditional way. I find that traditional way very time consuming and very tedious, especially when you got 10, 12, 13 observations there. I don't want to sit there and add up all of them one by one. It takes too long, and sometimes you make a mistake in punching in numbers or even doing it manually. So I like to estimate it. I'm going to pretend, see, I see in the low 20s, and I see in the high 20, and then low 30s and so forth. Let's pretend that the average is 30. I'm going to pretend that the average is 30, okay? See what happens. So, in other words, if we had 9 observations and every one of them were 30, then of course the average would have been 30. So I'm going to somehow force every one of them to be 30 by making the adjustment. 19, how do we make it 30? It is 11 short. This guy has a deficit of 9, this guy has a deficit of 8, this guy has a deficit of 8, this guy has a deficit of 2, this guy has a surplus of 1, a surplus of 3, surplus of 14, and a surplus of 20. Now let's see what happens. Okay, I need my hands free and I need to put 2, 3 different colored markers. Let's see what happens. And this doesn't take too long. You mustn't fuss about it. Just go, go, go. I see an 8, I see a 2, that's a 10. Let's make that into a positive 10. So in other words, I took away this 10 from that guy. Let's keep on going, let's not talk. Oh, there was no need for it actually. I could have taken out this 11 and 9 by 20, but it's too late now. I see a 14. I see 11 here. That means 14 becomes positive 3. I see a 9 here, negative 9. Let's take this guy out and convert this guy into a positive 1. I see, oh, that's it, we're done. I see a positive 8, negative 8, negative 8. 1 plus 3 plus 3 plus 1 is 8. So they all cancel each other out. They all cancel each other out, which implies that the average is in fact 30. The average is in fact 30. That's it, we are done. The average is 30. Now, like I said, if you haven't watched yesterday's video, watch yesterday's video. If you think this is too insane, you think this guy is crazy, he just looks in the back and see what the average is and he's just going to pretend the average is 30. That's not what I did. You just go with your gut feeling. My gut feeling tells me that the average was 30. Yesterday I was wrong. what I assumed, what I thought was going to be the average did not turn out to be the average. So if you want to learn how to do the adjustment, you just watch yesterday's video and you'll see it. That's it, we're done here. We're done here. I'm debating whether or not I should try it one more time just to convince you as to what happens, what might happen if you were to pretend something else. Anyway, the average is 30. The median, since there are since there are 9 observations, that makes it life easy. Since there are 9 observations, you're going to have 4 on this side, 4 on the other side. The guy in the middle is this guy, that's your median. So that's very easy. The mode, of course, is the most frequently appearing number. There is one observation that appears twice, that's your mode. The range is simply the maximum, the highest observation minus the minimum. The highest observation is 50, since everything is arranged in order, and the lowest is 19. 50 minus 20 would have been 30, so it's 31. The last part that we have to do is to find the interquartile range. Let's find that interquartile range. I'm going to start all over again for it because we need the room and so forth. So interquartile, we're done with the mean. We're done with the mean. Mean is 30. The mode is 22. The median is 28. The range is 31. To find interquartile range, we have to first find the first quartile and the third quartile, because the difference of the two is the interquartile range. We know the median is 28. We know the median is 28. What do these quartiles mean? Let's first talk about it. Whatever the observation that we have, we calculate 3 figures. They're called quartiles. This is how you might wonder why there are 3 of them if they are called quartile. Quartile simply means that we divide our observations. Sometimes it's called population if you have to, our samples or observations are the population if you have the whole thing. For example, if there's a class of 30, and if you were to ask every single child what his or her average is, and since you're asking every one of them, all 30 of them, it's referred to as population because there you covered the entire thing. On the other hand, if you were to randomly pick 10 children out of 30 and ask them what their average is and figure out the average from there, then that is not the population, that is called the sample. So whether you have the sample or whether you have the population, you want to divide up into 4 parts, and each part will represent 25% of the figures. Okay, 25% of sample. Let's speak in terms of sample. So the first quartile represents the top 25% or bottom 25% depending on how the numbers are arranged. Then you have the next quartile. So right in the middle is the 50th percentile. 50th percentile. That's your second quartile. Second quartile, because what it tells, second quartile tells us that 50% of the observations are below it and 50% of the observations are above it. But if the 50% of the observations are below it and 50% of the observations are above it, that is the definition of median. So second quartile is median. There is no difference. Median is the second quartile because the definition of median is that you arrange your numbers in order so that half of them are below it and half of them are above it. That's the 50th percentile. 50th percentile is the median, which is the second quartile. They're all the same thing. There are 3 different terminology, but they mean exactly the same thing. The first quartile is where you have 25% of the observation. Here in the second one, you have other 25% of the observation. So that's the second quartile. And then you're going to have your third quartile, where you're going to have the other 25% of the population, which is why you only need to figure out 3 quartiles. You see? The first quartile, the second quartile, and the third quartile. If you have a figure for third quartile, what it tells you is that 75% of the observations are below it. Third quartile means 75% of the observations are below it, and 25% of the observations are above it, which is same as 75th percentile. This third quartile is same as 75th percentile. Now, when do we speak in terms of percentile? One usually uses the terminology of percentile when one is dealing with a very large sample, very large number. We're talking about hundreds of observations, perhaps even thousands of observations. And when you're dealing with that, then numbers are assigned a percentile. You can figure out a percentile for any given number. So, for example, if I tell you that I just took the exam and my score, whatever that score was, translates into 68th percentile, what that means is that whatever my score was, 68% of all the people who took the exam with me scored below I did, which also means that 32% is scored above me. So if someone says that they are in the top 2 percentile, well, that's pretty damn good. Top 2 percentile means that 98% of the people who took the exam scored below that percent, and only 2% of people managed to score above that one. That's pretty good. So anyway, so we have to find the and the interquartile range, I never explained it. The interquartile range is this guy right here. This range, this is what they're talking about, right here. This thing here is the interquartile range, which is simply the difference between, why don't we do it here? Let me erase all of this thing. We know median is 28. Interquartile range is what I just showed you, is where is the mark for the first quartile and the third quartile, this middle 50% of the population, the difference of the middle 50% of the population, which is same as the third quartile minus the first quartile. That is your interquartile range. Voila, this guy right here. You ask yourself, what is the observation? Listen carefully. You ask yourself, what is the observation below which 75% of the population lies? And you ask yourself, what is the observation above which 75% of the population lies? That range is the middle 50%. You got your second quartile here, you got your third quartile there. The difference between the third quartile figure and the first quartile figure is what is known as interquartile range, which is what we have to do here. We already know the middle guy. The middle guy is right here. That's it. I really need the room, so I have erased most of this stuff. We already know the middle guy. The middle guy is right here. The 4 observations are above it, 4 observations are below it. So this is your second quartile. Now when we say the second quartile, means the 50% of the observations fall below it and 50% of the observations fall above it, listen very carefully, that statement becomes more and more accurate as your sample size increases. Here we have a very small sample, so obviously 4 of them are below it and 4 of them are above it. But these 4 observations do not represent 50% of the population, because we have 9 observations here. If we had 10 observations, then the average of the middle 2, whatever the average of the middle 2, would have been the figure where we could claim that exactly 50%, exactly half of them, in other words, 5 observations are below that, 5 observations are above it. But because we have 9 observations here, 4 of them are below it, which is not 4 out of 9 is not 50%, but it's approximately 50%. So the correct terminology would have been that this guy represents a figure below which approximately 50% of the population lies. And how approximate is it? That depends on how approximate are you, how accurate are you to exactly 50%. That gets closer and closer and closer to the real figure as the population, as the sample size increases. So when you're talking about hundreds of thousands of observations, as they are in the GRE, they give you the score, and in addition to score, next to your score, there is always a percentile. And that percentile is very accurate. Anyway, so this is the second quartile. The First quartile is the middle of these two guys right here, because two of them are lies below it and two of them are lies above it. This is your first quartile, which is the average of 21 and 22. The average of 21 and 22 is simply 21.5. Similarly, the third quartile is going to be the average of these two guys. Third quartile is the average of these two guys, 33 plus 77 divided by 2, whatever that happens to be. 33 plus 44. As you can see, the difference is 11, which means we have to spread the difference of 11 between the two of them. A difference of 10 would have been 5 and 5, so 11 is going to be 5.5. So it's going to be 38.5. That's your third quartile, 38.5. That's it. Therefore, the interquartile range, this guy we just figured out, is this guy right here, 21.5. This figure right here is 21.5. And this figure we just figured out is 38.5. Which tells us that 75% of the population is going to lie below it. Three quarter of the population is going to lie below it right here. This is the figure we're talking about here. And 25% of the population is going to lie above it. The difference between these two is your interquartile range. Therefore, the interquartile range here would be, let's see, where can we squeeze it here? Let's put it here. The interquartile range is going to be 38.5 minus 21.5, which is same as 38 minus 21. 38 minus 21, 38 minus 28, 38 minus 20 would have been 18, so it's just 17. That's your interquartile range. That's it. I think we're finally done with the first part. Do you understand? Of course, we could go much faster than that. Of course, we could go very fast and get the job done. But that, in my opinion, is not actually getting the job done. As I've explained to you many times, we're not here to solve problems. I'm not here to show you that I can solve the problem. We are here to learn. We have to learn, so you have to take your time. There is no rush. Just take your sweet time and relax. Understand? That's it. We are done. That is the end of it. Let's look up. I'm looking at as to what else they're asking here. Oh, they have a part B and a part C. Oh, Jesus. All right. Let's go to part B then. We need to erase everything. That's it. We're done with this thing. If each flight had 3 times as many passengers, if each flight had 3 times as many passengers, well, in that case, the mean would be 3 times as much. Mean would be 3 times as much. Why? Because every single observation is 3 times as much. Instead of 22, this is 66. Instead of 33, it is 91. This is 63. Every single one of them is 3 times as much, which means the mean is going to go by 3 times as much. That's all it is. Same thing with the mode. Mode would be 3 times as much. Our mode before, I believe, was 22 because we had two 22s here, right here and right here. We had 2 observations of 22. So now the mode is going to be 3 times 22. 3 times as much. That's it. Nothing is going to change. What about the range? The range is same as before. Maximum minus the minimum. Let's see what happens. Before, the maximum was 50. Now it's going to be 3 times 50. Before, the minimum was 19. Now it's going to be 3 times 19. Which of course is same as 3 times 50 minus 19. Three times 50 minus 19, which means the new range is 3 times the old range. Is 3 times the old range. That's all. What else are they asking here? If each flight had 3 times as many passengers, what would have been the mean? The mean would be 3 times as much, 3 times as the amount as before. Median, same thing, is 3 times the amount. The mode is going to be 3 times as much. We just talked about it. Oh, we never talked about the mode. Oh, right here, the mode is 3 times as much. The median, again, the median is also going to be 3 times as much. Median is not going to change anything. Whatever the median was, the middle guy, whatever the number was, it's going to be 3 times as much because everything is 3 times as much. The standard deviation and the interquartile range. Let's talk about them. So here we have 19, 21, 22, 22, 28, 31, 33, 44, and 50. One more time, because we have 9 observations, 4 of them are here, 4 of them are here. This is our median, which is same as second quartile. The first quartile is going to be the average of these two guys because 2 of them are below it, 2 of them are above it. The average of these two guys is 21.5. The third quartile is going to be, you're going to have 4 observations on this side, so the average of these two guys is going to be the third quartile, which is going to be, we found out, 5.5 more than 33, 38.5. Now what's going to happen? What is going to be our new interquartile range? Well, this is the old one. The new first quartile, since every single number is 3 times as much, we don't have 19 anymore, we have 3 times as much, we have 3 times as much, everything is 3 times as much. The new interquartile, whatever the average of these two was, the average of these 3 numbers, 21 times 3, is the new one is the average of 3 times 21 plus 3 times 22 divided by 2, which is same as 3 times 21 plus 22 over 2, which is same as 3 times the old quartile. That's all. It is same as 3 times the old quartile, first quartile. Same thing with the last one. This new third quartile is going to be 3 times the old third quartile. So what's going to happen to the interquartile range? What's going to happen to the interquartile range? It's going to be 3 times as before. Therefore, the new interquartile range is going to be 3 times the old interquartile range. Because this guy is 3 times as much, this guy is 3 times as much instead of 21.5. Instead of 21.5, the new one is 21.5 times 3. Instead of 38.5, the new one is going to be 38.5 times 3. Therefore, the new interquartile range is going to be 3 times 38.5 minus 3 times 21.5, which is same as 3 times 38.5 minus 21.5, which of course is same as 3 times the old interquartile range. That's all. What's going to happen to standard deviation? Let's talk about that. That's it. We're done with that part. Let's move on to standard deviation. Standard deviation tells us how spread out the observations are around the mean. The higher the standard deviation, the more spread out the observations are. The lower the standard deviation, everything is squeezed together around the mean. So for example, you see, I'm going to show you 2 normal distributions. This is one right here, and I'm going to show you another one, and they're going to both have the same mean, same average. Both of these observations are going to have the same average, but this guy has a much lower, or not the same average, sorry, the average is going to be different. Yes, the average is going to be same. I'm going to put them around the same average. But everything is squeezed together. Everything is squeezed together. And you see, we have a lot more observations at mean. This highest point there, this is the frequency here. We have not as many observations around the mean. Here we have a lot more observation around the mean, but the standard deviation is very little. Everything is squeezed together around the mean. So that's what the standard deviation shows you, how spread out the observations are. What's going to happen now is that because of the fact that every single observation is 3 times as much, the standard deviation, the spread around the mean is going to be 3 times as much. That's what it is. That's what it is. The new standard deviation. I need the room. standard deviation is going to be 3 times the old one, or 3 times 10.2. That's all. Whatever that works out to be. Let's go on to part C. In part C, they tell us what would happen if each flight had 2 fewer passengers. No. This is not the same as multiplying each figures by 2. We're not doubling every figure, we're not tripling every figure like we did in part B. We're simply adding 2 to each observations. So what would happen to mean before? The mean now. The mean is simply going to be less than before. That's all, because every single observation is 2 less than before, therefore the average is going to be 2 less than before. Same thing with the mode. Mode is going to be 2 less than before. Mode before was 22, now the mode is going to be 20. Because this guy instead of being 22 is 20 now, and this guy instead of being 22 is 20. This is 19 and this is 17. Everything is subtract, everything is 2 less. What happens to the interquartile range? The new interquartile range, which is what IR stands for, then the new interquartile range is equals to the new Q3 minus the new first quartile. The new third quartile is same as the old one, 38.5 minus the 2. Because everything is reduced by 2, so therefore by the time you take the average of these two numbers, instead of 33 and a 44, now we have 31 and a 42. And therefore their average is going to be 2 less than before, because each of these numbers is 2 less than before. So whatever it was is 2 less than before, minus the first quartile. First quartile was the average of these two guys, 21 and 22. Now we have an average of 19 and 20. The average of 19 and 20 is 19.5 instead of 21.5. You see, it's just 2 less. 21.5 minus the 2. Watch what happens as you open the parentheses. As we open the parentheses, we get 38.5 minus the 2 minus 21.5, and then this negative and this negative, this negative and this negative becomes positive 2. And what happens? Excuse me. What happens? This negative 2, and this positive 2 cancel each other out. And therefore, it's just 38.5 minus 21.5, which is same as the old interquartile range. The new interquartile range, the new one, is same as the old one. The range does not change because range is just the difference between the two numbers. The range will change if instead of adding a fixed amount to every observation, if you were to multiply everything by a certain number, then everything is getting larger, and therefore the difference between the lowest and the highest is going to be 2 times as many if each observation is multiplied by 2, or 3 times as much if each observation is multiplied by 3, like we saw in the previous part 2. But when you're simply adding the fixed numbers to everything, whatever you're adding to the maximum, it gets washed out by whatever you're subtracting from the lowest one, because you take the highest one and subtract the lowest one is going up by the same amount as the highest one is. They wash each other out and the range does not change. What happens to standard deviation? Let's talk about it. The standard deviation is going to remain unaffected. Why? Because whatever your spread was around the mean, that spread is going to be the same, except what happens now is that your mean is 2 less than before. Your mean is 2 less than before. In other words, every single observation is 2 less than before. So basically you have the same distribution, but it's just 2 less. Basically you're picking up the entire distribution, and you're picking it up and shifting it by 2 units. So the standard deviation remains unchanged because the spread around the mean is completely unaffected. That's what standard deviation is. It measures how spread out the observations are around the mean, even though the mean is 2 less than before and every observation is 2 less than before, but the way they are sitting around the mean does not change, and therefore the standard deviation does not change. It's going to be unaffected. That's all. And that's basically it. I will see you tomorrow when we'll do problem number 3. Again, do the problem ahead of time yourself, problem number 3, before you watch the videos. You'll get more out of it. Do the problem yourself and then do it together with me, okay? I'll see you tomorrow. Bye now.